This is JD, your teacher's assistant, and today we are going to be studying trigonometric ratios. Trigono means triangle, metric means measurement, and ratios are size differences across like a fraction or across a ratio. So, first we're going to look at triangles. There are 3 sides to every triangle, and when it comes to a right triangle, these have names. So first, you pick an angle. Normally it'll tell you which angle, but frankly it's just the angle. The opposite side of that angle, if you go from that angle and push to the other side of the triangle, that side is called the opposite. This is the opposite side of the triangle. If you look at the side that's touching the square of the 90 and the angle, that one's called the adjacent. And the side that's opposite from the square is called the hypotenuse. So it doesn't matter how you orient or twist or do anything to this triangle. It'll always have an opposite, an adjacent, and a hypotenuse. The opposite is opposite to the angle, the hypotenuse is opposite to the square, and the adjacent touches the square and the triangle and the angle. So opposite, adjacent, and hypotenuse. Opposite, adjacent, and hypotenuse. Feel free to pause and write down that and maybe draw some examples for yourself. So in this math, we can do ratios of the different lengths of these triangles. And each of these ratios has a special name. If you take the length of the opposite side divided by the hypotenuse, that's called the sine, often abbreviated to S-I-N. Sin. This is always this measurement. So when they ask you for the sine of the angle, they're wanting you to make a fraction out of the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. If you take this adjacent line, however long it is, and divide it by the hypotenuse, however long that is, you get the cosine of the angle, often abbreviated to COS. The tangent is when you take however long the opposite side is and divide it by how long the adjacent side is. So this opposite side, however long that is, divided by the adjacent side, however long that is. And this one is often abbreviated to tan, T-A-N. These are the 3 basic ratios. Now, these are kind of hard to remember. So, we have a mnemonic, SOHCAHTOA. Feel free to write this down. For when we have the sine of an angle, it's the opposite over the hypotenuse. So, S-O-H. When we have the cosine, it's the adjacent over the hypotenuse. Ka. Cosine, adjacent over hypotenuse. And for tangent, it's the opposite over the adjacent. TOA, T-O-A. The tangent is the opposite over the adjacent. They'll ask us to make these fractions. So, let's go look at some IXLs. They come from here, IXL PQJ. Let's practice some of these. So, they want to find the cosine of angle F. So let's first highlight our angle F. This is F. Okay, so cosine. Which one is cosine? Well, let's use our mnemonic. SOHCAHTOA. And I don't even need to write out TOA because we've reached cosine. So it's the adjacent over the hypotenuse. Let's find which one of these lines is the adjacent. Well, this one isn't because it doesn't touch our 1. And this one isn't it because it doesn't touch our square. So it's got to be this guy, 48. So we got 48 divided by, well, now we want the hypotenuse, and the hypotenuse is the side that's opposite to our square. So that's going to be 73. 73. So we now know that the cosine of our angle F is equal to 48 over 73. Now they want it to be simplified. I'm going to skip that step for now because I'm pretty sure this is simplified already, but you can go in and check and find out what our real answer should be by simplifying this guy into a more simple fraction. So let's move on to another one. This one, they want the tangent of angle U. So here's our angle U. So our tangent, tan, of angle U, they want tangent of angle U. So that's going to equal, well, let's go look at our SOHCAHTOA. TOA, tangent is the opposite over the adjacent. So let's find the opposite. Which side is opposite to angle U? Well, it's not this one because it's touching, and it's not this one because it's touching. So it's this one, 35. So our answer is 35 over, and now they want the adjacent. Which one of these is the adjacent? Well, this one is the square. So one that's opposite the square is going to be the hypotenuse. So therefore, the other one has to be it, which in this case is 12. So the tangent of angle U is 35 over 12. And let's see, 35 is 7 times 5. And 12 is 2 times 2 times 3. And so that doesn't reduce. So we actually know that this one is our final answer. It's giving us the ratio of our opposite over our adjacent. Let's do one more. Find the sine of angle Q. So first we're going to mark our angle, angle Q. Sine we know is so, the first part, so S-O-H, so. SOHCAHTOA. So we're wanting our opposite over our hypotenuse. So first let's find the opposite. Q here, the opposite side of the triangle as you go out, is this guy here, 45. 45. And our hypotenuse is, oh crap, we don't know our hypotenuse. Well, let's use the Pythagorean theorem. So we have 45 squared plus 28 squared will equal this side here, which I'm going to call RQ, line RQ squared. So let's grab our calculator and do that. So 45 squared, 2025, plus 28 squared. And now I'm going to take the square root of my answer, and I get 53. So by using the Pythagorean theorem, I know that this side has to be 53. So I get 45 over 53 because it's the opposite over the hypotenuse, that is my sine of angle Q. Alrighty. Feel free to go over to PQJ in IXL and practice this one. Here, if you have any more questions, feel free to ask Brenda in Help Hour. All right. Have a great day, everyone.